Hey, thank you for clicking on the video. I'm Van Tejas here to present to you a video on the applications of probability and statistics in the field of AI. Knowing probability. So, what's probability? Well, in a descriptive way, is a measurement of how likely an event may occur. It may happen or it may not. Most of us live every day knowingly or unknowingly using probability, like rolling a dice, getting a favorable number, tossing a coin, getting heads or tails, buying the lottery, hoping that we win the lottery, hoping, yeah, to be a millionaire, and like getting your results in a class, passing or failing. Probability is a measure of likelihood of how likely an event can occur. Is the chance of an event occurring, it can be favorable or it cannot be. Going on to the next topic, knowing statistics. Well, statistics is the science of collecting, analyzing, presenting, and interpreting data. Data are the facts and figures that are collected and used and summarized. Data is a raw sample which is then made into information. Statistics is the manipulation of data, including ways to gather, review, analyze, and draw conclusions from data. Statistics are the result of data analysis. It's the interpretation and presentation. Statistics are usually represented in forms of graphs and charts. Statistics lets us know things easily. Like example, if you have a product of a sale, by the stats you get to know if the product is going at what pace is the product being sold at. It's really helpful when you're running a business, and most of the people use it to gather information about anything they want. Going on to the next topic. So we come to the main topic here then. So what is AI? Artificial intelligence, also known as AI, is a wide-ranging branch of computer science concerned with the building of smart machines capable of performing tasks that typically require human intelligence. So, like machines don't have feelings and emotions, so they cannot be they don't have emotional thinking and rational thinking like human do. So what AI wants to do, or the people who want to enter the field of AI want to do, is make a machine, give it the power of thinking like a human, but not having any restrictions that a normal human has. So a machine with a man's intelligence and no restrictions like a man has. So AI is an interdisciplinary science with multiple approaches, but advancements in machine learning are creating a shift in virtually every sector of the tech industry. Well, AI at its core, AI is a branch of computer science that aims to answer Alan Turing's question, can machines think? Yeah. So basically where I started at, machines cannot think right now. Every Most of the people pursuing in artificial intelligence want to do this. Make a machine, give it the power of thinking through various other resources such as probability, statistics, and other information, and make it work like a human without any restrictions. The Alan Turing questions, back to the question, can machines think? It is the endeavor to replicate a simulate human intelligence in machines. Back, the ideal characteristic of artificial intelligence is the ability to rationalize and take actions that have the best chance of achieving a specific goal. A subset of artificial intelligence is machine learning, which refers to the concept that computer programs can automatically learn from and adapt to new data without being assisted by humans. Deep learning techniques enable this automatic learning through the observation of huge amounts of unstructured data such as text, images, and videos. In short, artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term may also be applied to any machine that exhibits traits associated with a human mind, such as learning and problem solving. There are six major branches in the artificial intelligence: expert systems, robotics, machine learning, neural network, fuzzy logic, natural language processing. We won't be going into this right now. Probability has various uses in AI like distributions probability, axioms, random variables, types of random variables, condition probability, independence, Bayes rules, chain rule, maximum likelihood, maximum a posteriori map. AI subjects of field can be categorized as learning, problem solving, uncertainty, and reasoning. Knowledge, representation, and communication. Probability is the bedrock of machine learning. It forms the basis of sampling. In machine learning, uncertainty can arise in many ways. Probability provides a set of rules or tools or to model uncertainty. Probability gives a set of tools for the machine learning to solve uncertainty. Many iterative learning techniques like maximum likelihood estimation are based on probability theory. For training in linear equation, logistic regression, and artificial neural networks, probability plays a huge role. Pattern recognition, which is a key part of machine learning, can be approached with Bayesian standpoint. Going on to the next topic, and we are coming to the last topic of our presentation, statistics in AI. Statistics is a collection of tools you can use to get answers to important questions about data, transforming raw data into information you can understand and share. Statistics is generally considered a prerequisite to the field of applied machine learning. We need statistics to help transform observation into information and to answer questions about samples of observation. Raw observations alone are data, but they are not informant or knowledge. Data raises questions such as what is the most common or expected observation? What are the limits on observations? What does the data look like? Although they may appear as simple questions, these questions must be answered in order to turn our observations into information that we can use and share. Beyond raw data, we may design experiment in order to collect observations from these experimental results. We may have sophisticated questions such as what variables are most relevant? What is the difference in an outcome between two experiments? Are the differences real or result of noise in data? Noise in data is like an error. Something similar to that. Questions of this types are important. The result matter to the product, to stakeholders, and to effective decision making. Statistical methods are required to find answers to the questions that we have about data. We can see that in order to both understand the data and use to train a machine learning model and to reinterpret the results of testing different machine learning models, the statistical method are required. This is the tip of iceberg. As each step in predictive modeling product, we require use of statistical method. I didn't go really deep into the video though. There's a lot in this field. If you want to learn, you can Google. And at the end, thank you. No cap.